Recording.
We started recording just now.
Sorry.
We will, like we are doing now, we will record the class so that you can watch it later, and you can work it around some other time. Okay? We just there will be no point for class attendance, but there will be a point for looking at the video that Morgan makes, or alternatively my old audios, which you will record yourself on the honor system in the Google Sheet. We just won't have a point for attending the class on Friday morning at 9 o'clock, which we will hold. And you can come if you want to, you don't have to.
Do you guys have any other questions about the remainder of the structure of the class? If you do, just go ahead and raise your hand or chat it at me. Okay.
While Morgan's waiting for more questions, I will say that the final exam is yet to be figured out. And we'll be working on that. The professors are all thinking about how to do things and have various ideas. And Morgan and I will discuss it and decide before long what we'll do for the final. Okay, so I want to...
Someone just asked, are we going to use digital dialogue each lecture? I just pulled it up on Learning Suite.
Yes, we will use digital dialogue each lecture, and I want you to go now to question 1 and hit reply in the lower right corner. I think that's how you answer the question, right? Once you've answered it, you'll be able to see what other people answered. So let me just pause for a minute or two. I have no idea how long. We'll figure out when most people have answered by. We're going to go through the first and third and fourth and fifth questions fairly quickly. The second, sixth, and seventh will probably take a while.
Okay, I'm getting some private questions. Let me just answer these real quick to everyone. So all the questions from lecture will be on the digital dialogue. So the digital dialogue questions, this is kind of the reverse classroom. Dr. Busaith comes up with the questions that are most important for the lecture video that I made to make sure that you get everything and that you start synthesizing the information, like how it's going to be on the final. And then someone said, if we answer wrong, do we lose points? As long as your answer is not completely out of the park, no, you won't lose any points. As long as it's at least you tried and made it a full sentence or two, then I'll give you all the points. It's only 1 point a lecture, so it's not like you're gonna miss. But honestly, this isn't graded like an exam. It's just more participation, making sure that you're actually trying to come to lecture if you can. So I know I have to do this on my phone and do some working. I have to do this.
The only way you could do digital dialogue is by your computer, eh?
Moran says your computer isn't working. Yes.
For those who can't get in by computer, just chat or text or email Morgan, and he will make sure you get credit for attending.
Yes, yeah, for sure.
You won't be able to see what everybody put on digital dialogue until you can get to a computer. And you wouldn't be able to participate in this quiz mode.
And they're only open till 10, so after 10 o'clock, what you put and what everyone else put goes away. So there really is a benefit for coming to lecture about getting the answers to all these questions. So, holy crap, there's so many questions.
Has anybody answered?
I haven't checked, sorry. And Graham just asked, are we going to post the correct answers? We are discussing the correct answers after everyone attempts to answer it. Does that make sense to you guys? Holy crap, I don't like all these questions. Okay, there's 11 people who have answered.
How do I get to see the answer?
You need to go over here and digital dialogue. I would just refresh this page.
That did it.
Perfect.
Okay, I'm kind of waiting until about 15 people have answered. I'm up to 12. I'm up to 14, so let's start going through it in the spirit of efficiency. This is a warm-up question to remind you of anatomy, the anatomy, and if you haven't had anatomy, it will be mind-boggling, but if you have, it'll just be review. So the glomerulus filters blood into Bowman's capsule, which then empties into the proximal convoluted tubule. After that winds around, it's convoluted for a little while. There's a dip down into the descending loop of Henle, which is like a trombone horn that invades, that pokes down into the medulla. In many of the nephrons, and then it comes back up through the ascending loop of Henle, which then goes to the, oh yeah, I should do that. Distal convoluted tubule emptying into the collecting duct. This is called the nephron, and it's the unit of structure in the kidney. Now the filtrate is going to be processed in the nephron. Basically, serum is filtered out of the blood and processed. So let's go to question 2 now to talk about the processing a little bit. Can anybody see question 2?
2 people are already into it. I've already responded.
My internet's not working either. I bet it did. This may be problematic if I can't even see the questions because I won't know what to discuss. Perhaps all of you can see them just fine. And I know we can have you turn on your mics and you do the discussing and I'll just listen.
Mine is just loaded if you want me to read it.
Okay, mine's back up too now. You should be able to get into it.
That's right. Let's see.
Read, Joseph.
I like what Jacob says exactly. As solutes move in from the capillaries. How are they moved in though? Active transport, Oscar points out, is how they are moved in, and then osmosis follows that active transport of solutes, but the real secretion itself, we're primarily referring to the solutes themselves, and there will be some osmosis that goes along with it. Okay, let's go on to question 3. What 2 cell types contribute to the glomerular filtration membrane? What protein layer separates them? How do mesangial cells affect glomerular filtration? Go. Okay. And just butt in whenever you want, like
Okay, we got it. Endothelial cells, fenestrated capillaries. Someone forgot the basal lamina, but
you talking to Marin? I mean, Marin.
Marin's here. Yay.
Hi, Marin. Good morning.
Good morning.
I'm so glad you made it.
Oh, yeah.
So since you may not be too clear on how mesangial cells affect glomerular filtration, we'll talk more about that. And if you are just stuck on that, go ahead and put in the answers to the first two questions. What two cell types contribute and what protein layer separates them? And then we'll talk about the mesangial cells.
Good. Let's keep looking.
Why don't you tell me when we have enough answers and I'll press forward.
Okay.
So I think
You've got plenty.
we have enough answers. Looking at the PowerPoint slide, the afferent arteriole brings blood into the capillary tuft called the glomerulus. And it's kind of coated by these podocytes, which are cells that have feet. That's what the word pod comes from. And they interdigitate so that when they expand, they block off the capillaries and you get less filtration. So the podocytes can create these filtration slits with their feet. The endothelial cells, the capillaries, are fenestrated and they can let fluid out. The fluid doesn't normally contain proteins or cells. It's just electrolyte solution. Water, salt, sugar, small molecules. Those get out and they have to pass through the protein coat called the basement membrane or basal lamina that separates podocyte cells from the endothelial cells. Now, intertwined amongst them are these mesangial cells, which can contract. They have some kind of like muscle property, smooth muscle-like property. When they contract, they pull on that basal lamina and that tightens up the filtration slits. So that even reduces filtration more. Let's go on to question 4. What fraction of renal plasma flow is filtered and what fraction of renal plasma flow ends up in the urine or as urine?
Oh,
Go.
we should get this. We did this specifically in my lecture. Let's see what this is.
Okay. Everybody that wants to is in or,
Yeah, we have 14 respondents.
okay. %20 of renal plasma flow is filtered, as you all got right. Most of that is reabsorbed. Only 1% is left behind to become the urine. So it's an opportunity or a chemical engineering magnificent machine that allows us to filter our blood and then reabsorb the good stuff. Now, the good stuff includes water, first off, because we're land animals and we can't afford to give up our water. The salt that we need, but not more than we need. The sugar, so that we don't waste nutrients. And a lot of other things, free fatty acids, and a lot of other things we need to keep, amino acids. But the things that we don't need to keep don't get reabsorbed. It's mostly a process of taking up sodium in the proximal convoluted tubule and water following osmotically. Okay, let's go on to question 5. Ready? What happens to the glomerular filtration rate, the GFR we call it, when afferent arterioles constrict? What happens when efferent arterioles constrict? Which of these two is used for the myogenic regulation of the GFR? And which two ion channel types in the arteriolar smooth muscle membrane mediate autoregulation? Go. What do you think, Morgan? Is this going okay? Think this is a good thing to do?
I think it's working okay. I don't know. What do you guys think? Are you muted?
I'm not muted. Give us thumbs up or thumbs down if you like or don't like what we're doing here today.
I'm terrible at recalling things, so I'm like trying to keep up as well as look through the book or the PowerPoint, the recording. So I'm kind of like, I'm following, but not really.
A little too fast, a little too much pressure. Need more time to look it up.
Yeah, so someone said it's stressful but helpful. Someone else said I don't like this at all. I'd rather just be told the answer. Someone else said it's good. It's good to have questions and the review of the question. I think it's working pretty well. However, I would like 1 additional minute to write down the correct answer after we discuss it. Stressful, that takes a lot of time. I don't know why you guys are so stressed. There's only 1 point and you just get it for being here.
Maybe they'll have to get used to it a little.
Yeah, someone said I'm bad at recalling things, so I feel very slow. Don't worry if you feel slow. Remember, you guys, this is going to be recorded. You can go back on YouTube and watch this again, and you can watch it real quick and get all the answers if you need it. Please don't feel embarrassed. If you want, we can make this so no one else can see your answers, but we thought that might be helpful to see what other students are putting. Someone said it's hard to keep up. Someone says I'm an athlete, so I'm dumb. That's what I said.
Nobody's going to pay attention to what you said, really.
That's okay. So majority of the feedback is good. I'll just email the person. Okay. Yeah, so I guess maybe less questions next time, a little bit more time to discuss and have the students. I think they'd really prefer that.
They
That's
might
what I'm
like to.
hearing.
They might like to chime in a little bit, not just hear me discuss it. Right?
Yeah, that's true. If you guys want to talk or you have questions, please raise your hand and ask us questions while we're going. Okay. We said only till 9:30, but our class time is from 9 to 10. So if we need that time to go over these questions, that's totally fine. Okay. Now, someone else said I like having a lot of questions. Someone said it's good. Oh my gosh. Wow. There's a lot of feedback.
You get what you asked for.
Oh, Sarah can't hear anything. Uh-oh, that's not good. Can everyone else hear us still? Like, give us a clap or a thumbs up if you can hear us. Okay, yeah, people can still hear us. Okay. Someone said, can we make some of these multiple choice or make them all multiple choice just to give us a little something to work? I don't know. We'll have to think about that because I feel like it's kind of good to have them be, I don't know, maybe.
The test will be multiple choice, and this isn't a test. This is more of a training exercise. This is more like, a wake-up call. Oh, the test was that. The second test was a good wake-up call. So was the pandemic and the earthquake. These are wake-up calls to help us go, I should dig a little deeper, pray a little harder, be fasting.
Someone says I love wake up calls.
All right, let's discuss this for a minute. What happens to glomerular filtration rate when afferent arterioles constrict? Okay, on the PowerPoint slide, here's the afferent arteriole constricting. What does that do? That increases the resistance into the glomerular tuft, the capillary bed. And so if there's less, if there's more resistance, there'll be less flow and there'll be more pressure drop. And so the hydrostatic pressure will be lower. That's what this pH is referring to in the glomerular capillaries. Now, if there's less pressure to drive fluid out, there's lower glomerular filtration rate. What happens if you constrict the efferent arteriole? Well, what that does is, I think of it as backup pressure. Now, there was less pressure drop through the efferent arteriole, which leaves more pressure in the capillary bed, which pushes more fluid out as filtrate. If you just relax the afferent arteriole, there would be less pressure drop, Poiseuille's law, through the afferent arteriole. So you'd have more pressure in the capillary bed and higher glomerular filtration. The myogenic response involves this one. Afferent arterioles, when stretched by high pressure, activate channels that are stretch-activated channels. They open up and depolarize the membrane of the smooth muscle cells. The depolarization causes voltage-gated calcium channels to open up. That lets calcium into the smooth muscle cells, and as we'll learn more in the future than we already have, now I guess as we review what we already have learned, we'll remember that that causes constriction. So more pressure, more constriction, less pressure in spite of the more pressure, so that your glomerular filtration rate comes back down to normal when it was previously above normal because of the high blood pressure. So that's the feedback loop, the negative feedback loop that preserves our glomerular filtration rate even, say, when we're exercising and our blood pressure goes way up. Does anybody have any questions about that they want to raise their hand or say a word? I hope not, because I want to go on to question 6. Be thinking though. We can go backwards too if you want to raise your hand, but let's press forwards for now. Question 6. Autoregulation is keeping the glomerular filtration rate constant even during fluctuations of blood pressure. The one we just talked about, the myogenic response, is just really stretch the smooth muscles and they'll constrict more, but there's one that's much more complicated. It's also autoregulation called tubuloglomerular feedback. In tubuloglomerular feedback, the glomerular filtration rate is autoregulated through sensing of what's in the nascent urine, namely the sodium. And the sodium load is the sodium concentration and the urine flow rate, the product of those two. As glomerular filtration increases, urinary sodium in the distal tubule increases in 2 ways, both because of the increased flow and also because the concentration goes up due to less reabsorption. So if the load is going up, what negative feedback mechanism reduces GFR? The key word here is mechanism. What negative feedback mechanism reduces GFR? And what I want out of you is, what are the cells that sense the sodium load? What paracrines do they send to what other cells to do what? Go.
Hey, I have a question for you, Dr. Busey.
Yes.
Someone said, so is it the afferent arteriole that regulates the myogenic response?
Yes.
Yes, it is.
Some of you just throw up your hands. I don't know. I give up.
Thank you for trying. That's all that matters. This was, at least for me, this was the hardest part of the lecture, understanding this mechanism right here. But maybe you guys are just better than I am at this. Oh, I got a question and I'm getting
Hmm?
Okay, Joseph, what's your question?
Is what we're looking at on the PowerPoint slide, is that related? Is that have to do with question 6, or is this the thing we just talked about?
That's what we just talked about.
So,
Yeah, question 6 is a different slide we'll pull up once we get some more answers in. Good question.
okay.
Someone says, I definitely will have to go back through this chapter. Yeah, Dr. Busey said the next 3 lectures are some of the hardest of this semester. So please don't feel bad if this is kicking your butt, because it's kind of supposed to. It's all downhill from here.
After the next few lectures. All right, let's talk about it a little bit. These cells, the macula densa cells, detect the sodium load in the fluid in here. Where am I pointing? This is the lumen of the distal tubule. This is a really cool aspect of the nephron that is mind-boggling to me. The proximal convoluted tubule gives rise to the loop of Henle, which comes back to the same glomerulus where cells in the nephron can sense what's going on in that nephron as far as the sodium load is concerned, and signal the macula densa whether it needs to secrete the paracrine adenosine or not. Adenosine or ATP, adenosine triphosphate, which gets converted to adenosine after it's secreted, both of them are released by these macula densa cells when the sodium load is high, because you're making too much urine, because the glomerular filtration rate is too high. And they, releasing the adenosine, activate constriction of these smooth muscle cells in the afferent arteriole, these ones, so that it brings the glomerular filtration rate back down. Okay, so if it's too high, the afferent arterioles constrict and bring it back down. Negative feedback, auto-regulation. Keep the GFR constant in spite of changes in blood pressure. Part of the reason for that would be that we undergo changes in blood pressure on purpose. There are times when our blood pressure, even though it's regulated, even though it's a homeostatic regulated variable, it needs to go up so that we can get more blood out, more through to our tissues. And that's particularly when we exercise. So if it's gonna go up, are we gonna increase our filtration rate and then urinate out all our water? We don't want to do that. So going back here to this autoregulation slide, our normal blood pressure produces a glomerular filtration rate of 180 liters per day. But if our blood pressure goes up, as it will during exercise, it might get up clear up to 180 millimeters of mercury. Do we want the GFR to keep going up, to 360, 540? Man, we would not be able to keep running because we'd have to pee so often. Okay, so no. Or more to the point, we don't want to lose the water from our bloodstream because it's crucial to us. So these two, the myogenic response and the tubular glomerular feedback, kick in to cut back on glomerular filtration, even though the blood pressure is going up. And we keep a constant GFR. Sweet, eh?
I have a couple of questions.
Go.
Okay, question one from someone. The book says that the macula densa is in the ascending limb of the loop of Henle. Does that matter? Because this slide said it's in the distal tubule.
I have never heard that before. I did not know the book said that. Thanks for pointing it out. I'll look it up and complain to the author.
Okay,
Or
and then
learn if I'm wrong. It's
someone,
always been in the distal convoluted tubule for 40 years of my life.
someone said, how does the adenosine get to the afferent arteriole?
It diffuses through these cells, amongst these cells, to get to the smooth muscle cells of the afferent arteriole. So it's not a very distant diffusion. Not a very big distance to go.
Where are you?
Okay, I got one more question. We're already at 9:40. Question 7. And this will put the final touches on tubular glomerular feedback and also introduce us to renin, which is released from granule cells. When tubular urine flow goes down, that gives more time for sodium reabsorption. So the sodium is even lower, the flow rate is lower. Between those two things, the sodium load at the macula densa goes up. I should have said goes down. That word is wrong where it says up. It should say down. And they release nitric oxide and prostaglandin, and that is the macula densa cells do. How does nitric oxide increase glomerular filtration rate? Prostaglandin stimulated granule cells stimulate granule cells to release renin. How does renin increase glomerular filtration rate? Go.
That one's going to be hard for you guys. We didn't cover what renin does. Renin. I don't know why it's pronounced
Either
that.
way.
I say renin. We didn't cover what renin does in my video, so just make your best guess. Don't feel bad if you don't get that right. It'll be covered in one of the next videos here, so this is just a little preview.
Right. The next one,
Oh yeah, it will be.
I think.
No.
Is it 2 away?
We'll see. I have to go back.
Yeah, I think you're right. It's 2 away.
Yeah. People are doing good with what I gave them. Good job, guys. I did not give you the answer to this one in the video. So. Oh, that's the next-
But it is right here on the slide, which we were just looking at. So, nitric oxide causes vasodilation of the afferent arteriole, which going back to our where'd that slide go? Darn it, I forget. Oh, here it is. So this slide is this situation. Vasodilation would increase the hydrostatic pressure. And that would increase the flow rate. So would renin release, because that increases mean arterial pressure through a cascade of enzymatic cleavages, namely renin or renin cleaves angiotensin 1. Angiotensin 1 is converted to angiotensin 2 by angiotensin converting enzyme. Angiotensin 2 causes smooth muscle constriction in the arterioles throughout the body to boost up the blood pressure when, say, for instance, you've got a bleed. And that will keep you from renal failure until the point that you can't get enough pressure in your arterioles to get any filtration, which then causes death. On that subject, if somebody gets coronavirus, COVID-19, and can't breathe, they will have global organ failure. One of the first things they have is kidney failure. The blood pressure droops. The kidneys can't filter the blood anymore. They will have to have dialysis. They will have to have a ventilator to pump air into their lungs. At some point, that might not do the job, and they'll have to be put on ECMO, extracorporeal oxygenation of their blood. So artificial lung, artificial kidney, you may be able to keep them alive, you may not. This last slide I include just to show you how detailed our knowledge has become in the past decade or so about what mechanisms are involved, for instance, in ATP release. The sodium load influences the sodium transport and across the membrane and the ATP release through exocytosis. And that stimulates the adenosine 1 receptor to cause phospholipase C activation of calcium concentration increase in the smooth muscle cell of the afferent arteriole, causing it to contract. Also, L-type calcium channels let the calcium go up as a result of increasing calcium and voltage gated effects due to depolarization of the cell. So that's what causes constriction of the afferent arteriole. That's it for today. Any
One more question.
last questions?
How long does it take renin to increase MAP throughout the body?
That is more like a minutes process, minutes to several minutes. So over the process of a few minutes, that would go on, 5 minutes maybe, before the enzymatic cleavages that take place, the distribution through the bloodstream. It takes 1 minute for a red blood cell to circulate through the whole bloodstream, venous and arterial sides. So that's a limitation of about minutes right there. I think that's it for today. Okay, we're going to do something similar to this, like this, to this on Friday.